Hello and welcome to this episode of Math with Martinez. We are in our Algebra 2, Unit 3, where we're discussing systems of linear equations and inequalities. And our learning objective in this video is that we will formulate and solve systems of two linear equations. Actually, our first several videos in this series are going to be all about that objective because there's lots of ways to solve. And the first way that we're going to see is solving by graphing. So solving systems graphically. But before we get into the actual nuts and bolts of doing that, let's just begin by defining what exactly do we mean by a system of equations. A system of equations consists of several equations containing two or more variables. And the solution to a system of equations is the set of points that make all the equations true. So what we're trying to figure out here when we're solving our system is what set of points makes every single equation in our system true. When you substitute it in, it actually maintains that equality on the left and right side. So let's go ahead and see about how that is done when graphing. We have this system of two linear equations with two variables, and we're going to graph them here in our coordinate plane because that is step number one. If we're going to solve graphically, we do need to go ahead and get started by graphing. And I want you to begin by doing this with me. Highlight your first equation red and your second equation blue. All right. Because we're going to color code these separate equations in our system so we know which one is which. Because they're not denoted with function notation, it's good for us to use different colors so we know which one is which. So step number one, we're going to graph each equation, but before we can graph these two in particular, we need to rewrite them in slope-intercept form. Remember slope-intercept form. I'm going to write that in the margin. Slope-intercept form is y equals mx plus b, where the b is your y-intercept. It's where you're going to begin graphing. I like the alliteration here, B for begin. And the m in our slope-intercept form is our slope. It's going to tell us how to move when we are plotting points on the graph. So let's go ahead and do that for this first equation. We're going to rewrite it down here. And we're going to make it look like this. We need to get y by itself. We need to isolate for y. So we're going to subtract the x on each side. So that would mean 2y equals, you could write it as 4 minus x, but I'm going to write it as negative x and keep my 4 positive because that fits more the format here, that the x is going to come before a constant. Then we need to go ahead and divide every single term by 2 to isolate our y. Give me just a second to adjust this ever so slightly. There we go. That's going to leave us with y by itself. Now I have a negative in front of my x. That's a negative almighty 1, so it's actually negative 1 over 2x. And 4 divided by 2 is 2. So that is my first equation that we're going to graph. And let's go ahead and do that. We're going to begin with our b value. Remember, begin with your b. So we're going to begin graphing on the y-axis at 2 because it is our y-intercept. And then from there, we're going to move according to our slope. We're going to move according to the slope, which is the coefficient of x. It is negative 1, so I'm going to go down 1 and then over 2. I'm going to go down 1 and then over 2. And that's where I'll plot my next point. And I can continue in that fashion, down 1 over 2. You could also go up 1, left 2, up 1, left 2. and that would follow the same rate of change. Then you go ahead and fill up your entire coordinate plane, going through every single one of those points. And you've graphed your first equation. And now we're ready to graph the second. Let's rewrite it. And let's put it in slope-intercept form. What are we going to do first? We're going to move the term that has x to the other side by subtraction, giving us negative y equals a negative 2x, and that is a positive 3. And again, be aware that that y is not yet isolated. It's technically got a negative 1, even though you don't see that 1 there. It is understood. It's multiplying, so we need to undo by division. A negative divided by negative is going to give us a positive 2x. And a positive divided by negative is going to give us a negative 3. So we begin. We begin at our b value. That is negative 3 on the y-axis. And y'all, it's called the y-intercept. Y-intercept. And so you need to graph it on the y-axis here, not on the x, please. Now from there, we're going to move according to our slope. Our slope is 2, so that means I go up 2, and technically my 2 is over a 1, right? Isn't that true? That I can express 2, it's the same thing as 2 over 1. A slope of 2 is 2 over 1. That reveals to you the rise and the run of the slope that you're working with here. Up to, oh look, it falls on that same point. And going backwards, that works as well. Hit all your points with your line, use a ruler, fill up your entire coordinate plane, and there you go. We have graphed our system. And the value that will make it true, the solution to this system, is the point where the two lines are intersecting each other. And so that's happening right here. That is at the point where the x value is 2 and the y value is 1. Our solution is the point 2, 1. Which we can prove, and I'm going to grab my graphing calculator to kind of show you guys that. It should make your equations true. So if you take the x and y value and plug it into your original equation, that red one, that would be 2, and then plus 2 times your value, your y value, which is 1, and that gives you 4, which is exactly what we were looking for. That red equation should equal 4 when you plug in the x and y. And for your blue equation, it's 2 times the x value, which is 2. And then we're subtracting from that the y value, substitute that in, put it in parentheses. Our y value is 1. And it's 3. So that is our proof that the value that we found for our solution, that ordered pair, 2, 1, is correct. So there you guys have it. That is solving by graphing. You're looking for that point where your lines intersect. That is the only point that will ever make both equations true. If you all had any questions about carrying out this objective of solving your systems of two linear equations by graphing, please take a moment to share those now. And until next time, stay fired up.